I need to just set it to record automatically when we come in. I should also point out on these recordings, I post them in Canvas. There's a link to the recordings and you can go watch them. They're on YouTube. So you can always go back and watch these lectures. And when you watch them, it'll have the screen and then it'll have a little window in the corner of me, but it actually, that window of me will switch to whoever's talking. So I hope everyone's okay with that. There's a possibility that you may be on video. If you're like completely against that, just let me know, like send me an email or something and I'll see what I can do. Okay, so back to this. We're trying to find a way to combine these together so we get this thing called a common denominator. There we go. And what we mean is we're going to look at the denominators of both of the fractions. So we're going to look at the number 4, we're going to look at the number 3. And what we're looking for, okay, when we say a common denominator, I should probably put here least common denominator, LCD, okay, we call this the LCD. What we're looking for is a number that is a multiple of 4 and also a multiple of 3, and we're going to try and find the smallest number that is a multiple of both. So what we could do is we could write the number 4 down. Okay, that's our first denominator. And we just start listing out all its multiples. So we have 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, 4 times 5 is 20, 24, and I could keep doing this, right? So I'm listing out all the multiples of 4. And then I do the same thing for 3. So I have 3 here, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 15, 18, and we continue with that list, right? And what we're looking for is the smallest number that appears in both lists, and that's called the least common denominator. So do we see that the least common denominator here is going to be the number 12, right? Number 12. That's the smallest number that's in both lists. So now what we're going to do is, and I'm doing this kind of all like scratch work on the side here. I'm going to take the number of the first fraction, 1/4, and I'm going to somehow try and convert it into something over 12 instead of 1/4. I'm going to try and make it something over 12. So what we do is we multiply this number, 1/4, we multiply it by a 1. And the reason we're doing that is because any number times 1 is itself. Do y'all agree with that? 4 times 1 is 4. 10 times 1 is still 10. So we're going to multiply by 1, but the 1 that we're going to use, we're going to be clever about it, right? What we're going to do is, I'm going to do it below here. We're going to take 1/4. I'm going to multiply not by 1, but by 3/3. Now, do you agree that 3/3 is still 1? Yes, but I'm multiplying it by 3/3 because look what happens when we do the multiplication. Remember, multiplication we did last time, you go straight across, right? If I were to multiply this straight across, 1 times 3 is 3, and then 4 times 3, that's 12. See, the whole idea here was to try and multiply by something that got me a 12 on the bottom, because 12 is my least common denominator. Does that make sense? I know a lot of you have seen this before, but I want to make sure we're clear on this. So we find our LCD 12, and then we somehow try and turn 1/4 into something over 12. And so we just have to think about what turns 4 into 12, 3, right? Now we have to do the same thing for the other fraction, 1/3. So what would I need to multiply this by in order to get something over 12? So question here. And let's go through our list today. We didn't get through everyone last time. So let's see, how about Abigail? What are you gonna need to multiply? Is Abigail here?
Yes, I'm here.
There you are. Okay, so Abigail, what are we gonna need to multiply this 1/3 by in order to get something over 12?
4/4.
4/4, yep. So 4/4, because 4/4 is 1, and then we multiply straight across. When we do that, we should get 4/12. Mm-hmm. So what we're saying here, and this is, I guess, the real important part of this is that I'm gonna move this down, and I'm gonna redraw our candy bars, but I'm gonna be a little more precise on my candy bars here. Yeah, this should work pretty good. So let's say that we have a candy bar, and gotta be real careful anymore. Okay, let's say we've got that candy bar there. And I'm supposed to take 1/4 of it, right? 1/4 of it. But instead of doing 1/4, I'm actually gonna take it and look at it as 3/12 instead of 1/4. So instead of cutting the bar up into four parts and taking one of them, I'm gonna cut it into 12 parts and take 3 of them. So I've got to cut this into 12 pieces first. So 1, 2, 3. So there it's 12 equal parts, and I'm going to take 3 of them. 1, 2, 3. Okay. So this is the 1/4, and then I'm going to do the same thing for the 1/3. So I'm going to take that candy bar, instead of cutting it into 3 pieces and taking 1, I'm going to cut it into 12 pieces and take how many? What was it? 1/3 is 4/12, right? So I'm going to cut this into 12 pieces. Okay, and I'm going to take 4 of them. 1, 2, 3, 4. And that's our 1/3. So now if I want to add those together, do you see that the pieces that I have are equal? Okay, they have the same length, as opposed to up here, this yellow and this green, they weren't the same. So I couldn't add those two together. So what I've done is, or what we've done is, we've somehow converted these fractions into something where they correspond to one another now. So now when I add these together, if I were to take, you know, I'm going to take 1 of those, let me do a different color. I have 1 of those, 2 of those, 3 of those, 4, 5, 6. Now I have 7 of those pieces out of 7 of those pieces out of a candy bar, right? So when I put that together, I should have 7 out of 12. All right, that should be our answer. All right, so that's visually what we're doing. Let's just kind of, what I want to do right now is I want to just kind of start the problem over, and we're going to go through a lot faster now. I just wanted you to see, like, visually why our answer should be 7/12. Okay, so now starting off, 1/4 plus 1/3. So the first thing we're going to do is we're going to find our LCD. Now I'm not going to write that list out again, but we know it's 12, right? And then what I'm going to do is I'm going to rewrite this. Okay, so this is kind of like the key part. We're going to do what we did over here, but we're going to do it right here in front of us. So I'm going to try and turn this 1/4 into something over 12. So I'm going to multiply the top and bottom by 3. And then over here on this fraction, I'm going to turn that into something over 12. So I'm going to multiply it by 4/4. Okay, so see how I'm doing that? Just right there with the problem that I was presented with. We do this multiplication, we do this multiplication, and that'll be our new line, or our new answer here so far. We said that that's 3/12 plus, and then we said 4/12. And now, if the answer is going to be 7/12, do you see that what we're doing is simply adding these two numbers up, 3 plus 4, and that gives us 7 on top? Now, are we going to add these two numbers together, 12 and 12? We are not going to add them together. We are going to keep them the same. We're going to keep that number the same. So this stays 12, and that's our answer. All right, so I hope that that helps, like a little bit of clarification why fractions are a little more challenging, because when you have different parts and they don't have the same length, you can't just add them together simply. You have to somehow find something in common with them first, and that's the common denominator. Let me give you a formula. All right, everyone likes formulas. So adding, so add or subtract fractions. and I'm going to put a little thing here, with same denominator. Okay, so let's say we're given a fraction, a over b. We want to add that to another fraction that is c over b. Now I want you to pay attention right now. Do you notice that those denominators are the same? If we have two fractions and they have the same denominators, that's the best case scenario. All we have to do is add up the top, a plus c, so we add those two together, and then we keep the denominator the same. And that's our answer. Okay? So adding, subtract, sorry, if we're going to subtract, the only thing different in subtraction is if this is a minus sign right here, the only thing changes is that this will become a minus sign right there between them. That's the only difference. So adding and subtracting fractions with the same denominators, I would argue is relatively easy. We can do one more here. Example. Let's say we do 3/5 minus 2/5. If we're asked to subtract those two fractions, first thing we do is we look at the denominators. We say, hey, they're the same, right? So all I'm going to do is do this operation, which is 3 take away 2. Keep my denominator the same. Then I have 1 on top and 5, so 1/5. Now, if they're not the same, we have to do the LCD, right? So if you want to add and subtract fractions not the same denominators, then you have to get an LCD first, right? LCD first. And then go through the method, right? So you get your LCD and then you just go back and do what this one is telling you to do. Any questions on that? I'm going to do another example with different denominators because that's the harder one to do. And let's just look at our problems from here. I'll just do this one right here, number 10. So we have 1/8. This is number 10 over there. We have 1/8 plus 2/5. All right, so we have to recognize that we're adding fractions together. We need to see, do we have the same denominator? Which we don't, right? 8 and 5. So let's see who is up here. So be thinking right now. You know what? Let me tell you who I'm going to call on, just to kind of give you, I'm going to give you kind of a heads up here. Abigail, I called on. The next person up is Taylor. Then after Taylor, we've got Denise. And after Denise, we've got Faith. And then we have Patrick. And then we have Lauren. So that'll be just to kind of give you all a little bit of a heads up who's coming up here. So Taylor, is Taylor here?
Yeah, I'm here.
Okay. So Taylor, you understand the concept here, LCD?
Mm.
Okay, so have you come up with an LCD for these two? You're looking at 8 and 5. You're trying to figure out the smallest number that's a multiple of both.
40.
40, okay. So did you do that in your head, or are you doing that just like on a calculator, or are you actually writing a list out?
No, I just did it in my head.
Yeah, so everyone's going to be at a different place here. Like everyone's got different levels of ability in terms of arithmetic. So if you're at a point where you just look at 8 and 5 and say, oh, the LCD is 40, great. I mean, that's what I'd hope for, but if you have to make a list, just make the list. Okay, so 40. So Taylor, if 40 is the LCD, then I'm going to have to multiply each of these fractions by something, right? So on this first fraction, 1/8, what am I going to have to multiply by top and bottom to create a 40?
5.
5, okay, so 5 here, 5 here. And then what about the other one?
8.
8, so 8 and 8. Okay, good, Taylor. You were off the hook. All right, so Denise, where's Denise? It's always hard to find. One of my complaints about Zoom is that your videos are in no order at all. We've asked them to make it so we can organize you, like even alphabetically or something, but they haven't done that yet. I don't see Denise. Is Denise not here? Yeah, no Denise.
Here.
Oh, there you are. Okay. Are you following this, Denise?
Yes.
Okay. So Denise, what would be the next step? We found the LCD. We decided what we're going to multiply each fraction by. So what's the next step?
Multiply
Mm-hmm.
5 and 1.
Yeah, so you're going to do this first fraction. You're just going to multiply straight across. What would that give you? I'm going to go ahead and write that down over here. What would you get?
That would give me 5
Over
over 40.
40. Okay. And then we're going to do plus because there's a plus. And then now you do the second one, right?
Yes.
When you multiply across there, what do you get?
16.
16 over
40.
40 again, right? Okay, good. Now at this point, where are we here? Faith? Where's Faith?
Yeah.
I know I saw Faith. There she is. Okay. So Faith, at this point, you're looking at two fractions, right? They have the same denominators. So this is what we wanted, right? So what are you gonna do?
Yeah. We're gonna add the 5 and 16,
Yep,
which would
just
be
add the
21 over 40.
21 over 40. There you go. So if you take 1/8 of a candy bar and you add it to 2/5 of a candy bar, you're going to wind up with 21/40 of a candy bar. Okay. How does that feel to you? Does that make sense? Let's do number 11. I like 11. 11 looks pretty good. 7 3/5. That's a mixed number. And then 1/2. Okay, Faith is out of here. Thank you. And now we're at Patrick. Patrick around?
Yeah, I'm right here.
We are. Okay, Patrick. So Patrick, are you following this all right?
Yes, sir.
All right, so we have this different thing happening here because we have this mixed number, right? And we need to deal with that first, Patrick. So do you remember from last class how we convert that to an improper fraction or a proper fraction?
It's like 7 times 5 essentially, plus your 3.
And then you add the 3. Okay, good. So that's something we did last class. So we do 7 times 5, that gives us what, 35? Then we add 3 to that, we get 38. So we have 38 over, Patrick, what do you put that on top of again? I forgot.
5.
Yeah, you keep the 5. Okay, good. And then now minus 1/2. So now, the first step there was to get everything in terms of proper fractions or improper fractions. Get rid of the mixed numbers, okay? Now, Lauren, where's Lauren?
Yes, I'm here.
There you are, Lauren. We've got, coming up after Lauren, we've got Bethany, Jesus. I called on some of you last time. So Roman, Min, Anastasia, and is it Kira? I think it's Kira. Y'all are kind of the next 5 or 6 coming up here. So, all right. So where was I? I forgot. Where are you? Where'd you go?
Oh, I'm right here.
Lauren. Yeah, I called Lauren. All right. So Lauren, what now?
We find the least common denominator.
Okay, yeah, because we've got two fractions, we're trying to subtract them. They have different denominators. So we need an LCD. What is the LCD?
I'm gonna guess 10.
10, okay. That is correct. That is the smallest number that is a multiple of both of those. Now, have you all noticed that the LCD in the problems we've done, have you noticed that the LCD seems to always be the two numbers multiplied together, like the two denominators? That's not always the case. Okay, so just we got to be a little careful with that. The LCD is not always just those two numbers multiplied. I'll give you an example after this, all right? But in this case it is. So, all right, so Lauren, we're going to have to turn these things into tens. So we're going to have to multiply the first fraction by something, second fraction by something. So Lauren, do you know what we're going to use there for the first one?
Yeah, so the first one's going to be 2 over 2, and then the next
Good.
one's going to be 5 over 5.
Good, okay, perfect. And now we do the multiplication. So we'll move on to the next contestant. I'm trying to find where I am here. Bethany? Is Bethany around? Where's Bethany?
Yes.
Hey, Bethany. Okay, this all okay, Bethany, so far?
Yeah.
Okay, so we want to multiply these together here now. We want to put those together, multiplication straight across, multiplication straight across. Numbers are going to get a little big here. So what do you got across there?
The first one is, I think it's 76 over 10.
Okay, good. And then minus, right? And then the other one
Yes.
is,
5 over 10.
okay, good. Now we have the same denominator, which we're happy about. And we're going to do what now?
Minus 76 minus 5.
76 minus 5, which gives us 71 over 10. We're done. It's kind of weird because if you think of this as like a candy bar, it's saying we're going to take a candy bar and cut it into 10 pieces. And then how many are we going to take? 71 of those, right? So we're going to have more than one candy bar. Every 10 pieces we have makes up a candy bar. So we're going to have 71 pieces. So we're going to have more than 7 candy bars, right? All right, now, just to be kind of consistent with what I said a minute ago, we have to be a little careful. So I'm just going to make one up here. Let's say we have 7/12 plus, how do I want to do this? Yeah. Plus 8/15. There we go. That's a good one. So we definitely have different denominators, right? We've got to try and come up with an LCD. And it's, I think a problem like this, it's not as obvious what the LCD is, right? So we might have to actually make a list. Okay, so I'm going to start making a list here. Multiples of 12. So 12, 24, 36. And I might, I might need my calculator for this. I might actually have to start doing like 12 times 3, 12 times 4, 12 times 5. But I'm just going to keep going here. Just going to do the first few. And then let's just make the list of the multiples of 15. So 15 times 1 is 15. 15 times 2 is 30. Times 3 is 45. Times 4 is 60. Ah, you see, we got it there. 60. So if you had just multiplied 12 times 15, you would have had a really big number, right? But the actual LCD is smaller than 12 times 15. It's just 60. Does that make sense, everyone? Is that any questions on that? Okay, so now we do have to think about what we multiply by. So what do we multiply 12 by to get 60? So I did 12 times 1, 2, 3, 4. It's 12 times 5 to get 60. So 5 here, 5 here. And for 15, I had to multiply by 4 to get that. So 4 on top, 4 on bottom. Then I do these, go straight across on those multiplications. So I should get 35 over 12 plus 8 times 4 is 32 over 12. And we can add now, we have the same denominators, so just add up those numerators. What's that, 67 over 12. I went through that kind of fast, but the main point of this was just to show that the LCD is not always just the two denominators multiplied together. Sometimes you actually have to make the list.
Should the
Did I mess something up? What did I do?
It should be 60.
12.
What? Oh, my denominator, right? Oh my gosh. Why did I put 12? Thank you. I'm glad y'all are paying
I was
attention.
getting confused. I was like,
Yeah, I mean, all of a sudden the world comes crumbling down around you. Like, what the hell happened? Yeah, no, this is our LCD of 60. Yeah, if I do something like obviously wrong like that, please don't hesitate. Trust yourself. Trust that you're not going crazy. It's me. Okay. Okay. So, with all of that said, I also want to point out that there is a formula. Okay, there is a shortcut formula for adding and subtracting fractions that you are free to use that doesn't require anything that I just showed you. But there's a little bit of a downside to it. So I want to show it to you on a test, or moving along in the future here. You can use whichever method you want. I just didn't want to start with formula. I wanted us to all understand what it takes to add two fractions together first. So here is a shortcut formula. So adding, subtracting fractions. Okay, and I'm not going to say with same denominators, without. This works for any fractions at any point in time, always. Okay, it's A over B, so let's say we have a fraction, plus C over D. So we have two fractions, we want to add them together. The formula is A times D plus B times C over B times D. Now that may look weird, but let me just kind of explain. Let me show you how it works first. And then once you see how it works, I'll try and explain why it works. All right, so let's talk about the pieces. So this A times D, do y'all see that that's just me multiplying this times this, right? Multiply those together. Then you add, because there's an addition symbol here, we're just going to do addition here. And then B times C, do y'all see that that's just these two multiplied together? So it's like you're multiplying across one way, and then you're adding to that, multiplying across the other way. And then the B times D, do y'all see that that's these two multiplied together, the denominators? That's the formula. So let's go look at the first example we did. It was 1/4 plus 1/3, right? And remember our answer on this was 7/12, right? So let's try this method. The first thing we're going to do is we're going to multiply this 1 times 3. Right, so we're multiplying across. So 1 times 3, that gives us 3. We put that up here. Plus, now we're going to multiply the other way. This 4 times 1. So 4 times 1 is 4. We put that there. And then the denominator is just these two things multiplied together, which would be our 12. And how do you see that that's 7 over 12? Any questions on that? Isn't that nice? Shouldn't I just shown you that to begin with? So let's do the second example we did, which was 1/8 plus 2/5. And let's just do the same thing. I think the answer here, if I remember correctly, was 21/40. 21 over 40. Is that our answer? Yeah. Okay, so let's do it. First multiply across there. That gives me 5 plus, and then let's multiply across here, and that gives me 16. And then on the bottom, I do the denominators multiplied, that's 40. I add up the numerators, 16 and 5 add up to be 21 over 40. Y'all like that? You get the idea of the cross thing and then go across. It's so fast, right? It's very, very quick method. Let's look at the last example we just did. The last one we did, and I've kind of forgotten what it was. 7/12 over 8/15. Or plus, sorry, 7/12 plus 8/15. All right, let's just follow the method. Do you see kind of an issue right now? 7 times 15, that's gonna be kind of a big number, isn't it? So 7 times 15, we get our calculators out if we need to. What is it? 105? It's 70 plus 35, yeah, it's 105. Plus, now we have to do 8 times 12, which is gonna be what, 96? Ooh, and I'm gonna need your help on this one. Then we have to do 12 times 15. What's 12 times 15?
180.
Is it 180?
Yeah.
Okay, and then we add up the numerator. So if we add up the numerator, we're gonna get 201 over 180. That doesn't seem like the answer we had, does it? We had 67 over 60,
We
right?
have to reduce it.
Yeah, so look, you know, this formula is pretty nice, but there's a catch to it. You might still have to reduce your answer. Like, you're gonna get an answer, it's gonna be correct, but it may not be in its completely reduced form. So this is where you'd have to sit here and think about, like, is there a number that goes into both 201 and 180? And there is. I think 3 goes into each one. So you'd have to get your calculator out and just do the arithmetic. Where did my calculator go? Hold on a second. There it is. Right, so you might have to mess around with the numbers a little bit here. But that's really the only drawback to this method, is that your numbers can get big. So if 3 goes into this 67 times, and 3 goes into the bottom 60 times. And that will take you to your answer we had before. Let me also point out to everyone that if we had subtraction between these, the only thing that changes is in this formula, we would have a subtraction in there instead. Otherwise, everything else is the same. Okay, no questions? It's word problem time. All right, so these word problems are always an issue, all right? Because they're word problems, that just always causes, you know, people trouble. So let's see how we can use addition, subtraction, multiplication, and division of fractions to try and solve these problems. Has anyone had any issues trying to get the this packet online to be able to have it, a copy of it for yourself? Anyone have any issues? All right. All right, so let's read through this first question. Dolores sold candy by the pound. The first person who came into her store bought 2 1¼ pounds of gumdrops. The second person came in the store bought 5 3/4 pounds of jelly beans. How many pounds of candy did Dolores sell to her first 2 customers? So who wants, well, you know what, we'll just go down the list here. I'm gonna call on somebody here. I've forgotten where I am. Was Bethany the last person? No. Samantha, no, I'm not calling you. I'm giving you time to think right now. All right, how about Jesus? Is Jesus here?
I'm here.
Okay. So Jesus, you read that question. What operation are we going to need to use here to figure out this answer?
Addition?
Addition, right? So she sold so much to the first person, so much to the other. So for number 8, what we need to do is take 2 1/4 pounds and add that to 5 3/4 pounds. And that would be the total, right? So Jesus, if you were asked to add those together, what would be your first step?
Multiply 2 by 4, add 1, multiply
Okay.
5 by 4, and add the 3.
So you would convert the mixed numbers over to the improper fractions first, and then do whatever, right? Good. Okay.
Correct.
That's what I wanted to hear. So I'm actually not going to work through these. We're gonna convert the word problems into the math, and then the math I'm gonna let you take, do on your own. Not right this second, but let's look at the next problem. Good job, Jesus. Everybody's doing a good job. I really appreciate everyone being engaged and feedback and all that. I hope at least on your end you feel like this will be better than me just sitting here doing problems all day. Okay, let's do number 19. In language arts class, make this a little bit bigger so y'all can read it. In language arts class, the class was assigned, well, I can't reach, sorry. In language arts, the class was assigned to write a team paper. Each team has to write 5.5 pages for the combined paper. When all the teams put their papers together, there was a total of 44 pages. How many teams worked on this? All right, let's think about that while I mark Jesus off here and look at our next volunteer. So Roman, you're the lucky one. Looking for Roman. Don't see Roman. I don't think Roman's here. All right, so Roman does not get credit. All right, that means that Min, am I saying that right? Min?
Yes.
I did say that okay?
Yeah. Can you hear me?
I can barely hear you. Is that the best audio you have? Because if it is, what's that?
Can you hear me now?
Yeah, it's a little bit muffled. So I'm gonna pass on you because I want everyone to be able to hear you. I'll give you credit, but let's see if we can't get that audio better next time. That unfortunately forces Anastasia. Where's Anastasia?
Here.
Here, oh, we can hear you loud and clear. All right. So what are you thinking here, Anastasia?
I'm
About-
honestly not too sure. It kind of sounds familiar to 18.
Okay. So with word problems, here's my recommendation. Whenever you have something where you're confused, I always try and make the numbers into something that my brain can process better. So I'm going to come over here to this, and I'm going to change some things. Okay, what I'm going to do is I'm going to get rid of the 5 halves, and I'm just going to make it 5. Okay, and instead of 44 pages, I'm going to make it a nice even number. I'm going to make it, I don't know, 40. Okay, so now Anastasia, let's read through this again. You had in language arts class, they were assigned to write a team paper, right?
Yeah.
Each team had to write 5 pages. Okay, each team had to write 5 pages. When all the teams put their papers together, there were 40 pages total. How many teams worked on this?
Oh, are we dividing?
We're dividing. Okay, do y'all see how much easier it is to understand the problem if you make the numbers a little bit easier to work with in your head?
Mhm.
So if we kept the problem like that, you would be taking 40 and dividing it by 5, right? You have 40 pages total. There were 5 pages on each team wrote 5 pages. So if we take 40 and divide it by 5, we would get 8. And that would tell us how many teams we had, right?
Yes.
Does that make sense to everyone? Does it seem a little bit easier to do it that way? Now that we know what the operation is, let's just clear that out. And let's do that same thing, but with the numbers we have, right? So we are going to be taking the total number of pages, which was 44, and dividing it by how many pages each team did, 5.5. Does that make sense now? Yeah?
Yeah.
Now, we're not going to do this, but the first step we would probably want to do is to convert that, right? And also, I'm going to write it a different way. Watch the way I write this. I'm going to write 44 over 1 divided by, now if I did that, that would be 11 over 2. That's what that conversion would be. Now, at this point, you just have 2 fractions. Notice I put 44 over 1 so that it would look like a fraction. So I've got a fraction divided by a fraction, and we learned last class that's the keep dot flip thing. So that's how we'd finish that out. Okay, good. I'm glad we went through that one. Okay, let's go with the next one, number 20, and we are going on to, let's see, I've got Kira, then it's Abigail, then it's is it Lati? Wait,
It's
Tatiana?
Tatiana. Tatiana.
Wilson? Oh, wait, on
Yes.
my thing. Okay, so don't worry about the LA there.
Yeah, Tatiana
Okay,
is
I'll
fine.
take that out. Okay, so we'll have Tatiana, and then we'll have Victoria, then I think it's Carolyn. Okay, so that's who's coming up. But right now we have Kira. So is Kira here? And am I saying that right?
Yeah, I'm here.
Okay. All right, Kira. Let's read through number 20. I'll read it out. Dennis's new dog weighs 127 3/4 pounds. That's a big dog. His friend's dog weighs 94.5 pounds. How much more does Dennis's dog weigh than his friend's? What do you think?
I think you would subtract it from each
Okay.
other.
Subtraction. I think we could all agree that's subtraction. Now, we have to be careful, Kara, right? Because in subtraction, the order that you do subtraction matters. So like if I ask everyone, what's 5 minus 7? That is not the same as saying what's 7 minus 5, right? So the order in which we subtract here is going to matter. So which one is going to go first? Which one are you subtracting from what?
You would subtract the 94 from the 127, I think. So
Good.
the bigger
Yeah, so
number.
listen to the way Kara said that. We're going to subtract the 94.5 from the 127 3/4. So the way we write that is 127 3/4. We are going to subtract from that 94 1/2. Okay, this is number 20. Now, each of those are mixed numbers, so they would first have to be converted over to improper fractions. They're going to be huge numbers, but it can be done, right? And then once you have your fractions, you can combine them using the formula, or you can do the LCD method. Okay, that's all I want to do is just get these things set up and leave it to you to try and put them together. Just do one more. And that was Kira. We are now Abigail? Abigail here?
Is it me again? Because I think I was the
Right.
first one to go, but
You were the first one to go. Maybe we got 2 Abigails, no?
There's multiple in the class.
Well, okay, so I have an Abigail, Della Rosa, and then I have an Abby. So I have an Abigail and an Abby. So who's already
Okay.
gone?
I'm here.
Abigail De La Rosa. I went first, I think. But
Okay,
I don't mind going again.
I want to make sure that I have, okay, so Abigail, you went already.
There's
You
another.
go, Abigail, do you go by Abby or no?
I go by Abby, but since there's like 3, you can call me Abigail.
Do we have 3 in here? Okay, so we have Abby, Ruiz,
That's me.
Abigail. Yeah, we've got 3 Abbies. This is gonna be tough. All right, so let's go with Abby P. Is Abby P?
Yeah.
Where are you at? There you are. Okay, I see you now. So Abby P. So I think I might just have to call you all by your, Abby D, Abby P, Abby R. All right, Abby P.
Okay.
I don't even know what I'm asking you. Let's look at these problems. How about 23? Joy and her friend wanted to do something different. They decided to go to the track and see how many times they could run around the track without stopping. When they finally finished, their stopwatch showed that they ran a total of 23 2/5 minutes. If on average, Joy also knew it took them 4.5 minutes to run around the track once, how many times did they make it around the track? So how many laps did they go? So what do you think here? What's the operation that we're going to be doing?
Yeah, I'm thinking.
Abby, can I change the numbers for you?
Yes.
Okay, what if this was 100 minutes? And what if this was 5 minutes? So what if it said that they ran a total of 100 minutes and on average it took them 5 minutes per lap?
Would you
Then how
divide
many-
that?
You would what?
Divide?
Yeah, you would take your 100 and divide it by the 5. I really do hope that that helps. I mean, honestly, I've done that in the past. Like if the numbers are messing me up, I just try and make them nicer numbers and then see if that helps my brain process what the operation is. If they ran for a total of 100 minutes and each lap took them 5 minutes, then I'm going to have to see how many times 5 goes into 100 in order to figure out how many laps they did. So for us in this problem, we're going to not do that. We're going to do the same operation, but we're not going to use 105, 100, and the number 100 and the number 5. We are going to use 23 2/5 and divide that by 4 1/2. Okay, good. That's all I'm gonna do. I'm not gonna go through every one of those. Here's your homework, as you can see. And remember, I don't collect homework for a grade. I do expect that you are doing it. That's the way you'll do good on a test, right? Like I said the last time, if you're sitting here watching me do this and you're like, yes, I know how to do this, I know how to do this. That's great, but still you need to practice a little bit, because if you just watch me and then go to the test, you might start making mistakes because you just hadn't been doing it. So just be careful with that. Do as much of this as you can. There's some word problems in here. And if we have questions, I think next class we'll have questions at the beginning over this homework assignment, because there's lots of word problems and people are probably going to get tripped up on them. But that's it for the homework. Let's start talking about order of operations. I do want to get started on this today. We have another 20 minutes or so.
I had a question
Yep.
about the homework.
Yep.
Online it says only the odd numbers, but would you like us to do all of them?
Yeah, do what the schedule says.
Okay.
Okay, but if you're looking for, like, when the test comes around and you're like, is there anything else I can do to study or get ready? Just try and do as much of the homework as you can. Like, do the evens also.
Okay, thank you.
I'm sorry, is that it?
Oh, thank you.
Okay. If we look at our schedule, we actually have a test pretty soon, right? Our first test is not next week, but the week after that, on Tuesday. So, and now today we're supposed to start order of operations, and we were supposed to get all the way through linear expressions and equations. There's no way that's happening. So our first test will cover only what we get up to, all right? So I'll probably be making some adjustments to this, just so you know. I really have taken my time through that first section with the fractions, and I'll probably start speeding things up a little bit, but we'll just see how it goes. Like I said in the beginning, this is a college algebra class for people who are not moving on and doing more math. So if we don't get through every single thing here, like, it's fine. Like, the world's going to keep spinning. We're okay. Nobody's going to go build a bridge or an airplane after this class, so we're not too concerned. But we want to work at a real honest pace. All right, we can't go too slow. All right, let's talk about order of operations. This is always fun for me. I'm going to put a problem up here, and then I'm going to give you, this is going to be a multiple choice problem. I'm going to take a poll. So what I'd like for you to do is figure out what 16 divided by 4 times 2 is. All right, so you know what, I'm not gonna give you, well, yeah, I'll give you the answers, choices. First choice is going to be 5. Second choice is going to be 2. Third choice is going to be 8. And the last choice is going to be 0. All right, here comes the poll. And this is an anonymous poll, so no one's going to know who said what. Here it goes. Do you want, like, the Jeopardy music in the background or no? All right, I think that's everybody. We're missing one person, but it could be that the poll's not working for them. Oh, no, that's every, no, not yet. Okay, I'm gonna stop the poll. Here we go. That's about what I was expecting. Do y'all see those results? It's about 50-50 there. So the two answers we're getting are the 2 and the 8. Those are the ones. Okay, so who wants to volunteer? Somebody who selected B. Does anyone, do any of you that did that want to kind of explain why and how and everything else? I saw Sammy's hand go up. Sammy, do you want to? Now you're giving it away to Taylor now?
Doesn't matter.
Okay, go ahead, Sammy.
Okay, I just followed PEMDAS.
PEMDAS. Okay, so that's a thing we use to help us with order of operations. That's part of what this next section is about. I'm going to write it down. PEMDAS. When I was a student, I was taught this little acronym, please excuse my dear Aunt Sally. That's what I was taught. That's a way that I learned it to remember it. And what it meant was you do the parentheses always first, right? Then you do exponents, then you do multiplication, then you do division, then you add, and then you subtract. Okay, continue, Sammy.
So I multiplied first.
So you multiplied the 4 times 2 first,
Mhm.
which gave you 8, right? So you were there and you had 16 divided by 8, and that gave you the result of 2. Makes perfect sense, okay? Somebody who answered part C, want to explain what they did?
My poll wasn't working, but that I thought C was the answer, so I can go.
Okay, so why did you do C? Why did you do 8 and not 2?
I put the parentheses around the 16 and the 4, and so then I divided first and then multiplied by 2.
So why did you divide first?
Because it's in the beginning. I don't know. I always go from like the beginning to the.
You always go from like left to right, the way you read a book, kind of?
Yeah.
Okay, you all ready for the correct answer? It's 8. And you're gonna sit there and go, what? Like half of you are gonna go like, what? Because Sammy, your explanation is perfectly reasonable, right? You just followed PEMDAS, right? The problem with PEMDAS is a lot of times it's not taught, well, I'm not gonna say it's not taught correctly. It's just not emphasized that the multiplication and division in PEMDAS are equal, meaning that you don't do multiplication before division. You do multiplication and division together, and you do it in the order from left to right as you read a book. Okay, so this always goes from left to right. Left to right. Unfortunately, people remember PEMDAS and they always think multiplication before division. And I'll be honest with you, I think it's taught that way also. I think it's taught incorrectly by some people. And so, of course, now you get here and you're like, oh crap, I was taught the wrong way. Well, addition and subtraction are also grouped together. It's not addition before subtraction. It's always left to right also. All right, so good. About half the class kind of learned something new today for sure. The correct answer here is 8. So we get that by doing what Abby had said here. We see that we have multiplication and we have division. So no, neither one of those get preference. We're just going to read it from left to right. We do this first. So 16 divided by 4, that gives us 4. And then we say times 2, and that gives us our 8. Okay. All right, so order of operations. This order of operations right here is important. Not only is it important, that we know that there's an order of operations, it's important that we all follow the order of operations, because it's pretty easy to see here that if we didn't all agree upon an order of operations, then it would be quite possible that we get different answers, right? And in the real world, if I'm an engineer and I'm building something and I have to calculate, you know, how much load some beam on some bridge is going to take before it crumbles, my math has to be consistent. I can't come up with the answer 2 when someone else is calculating 8, right? So we all have to agree upon the system and the way we're going to do things, and then from there, everything else is built. So it's a very important, I guess, procedure that we follow this. We just have to follow it correctly. All right. Now, let me just add one more thing on top of that. Could we have designed our order of operations? Could we have and said, you know what, let's just all agree that multiplication comes before division? Yeah, we could have. We could have said that. We could have just said, hey, let's just agree that that's the way it's going to be. And then we would all get the same answers. We would have all got the answer 2 here. But at least we're all getting the same answer. That's the point. All right? Okay, so let's look at some problems here. We are going to be doing order of operations on these things here. PEMDAS. Now let's see how much of this we can actually get through. So this first one, We're going to be doing 5. We need to take away 3. We need to add 72, parentheses, 10, take away 2. All right. So PEMDAS I'll put up here. And I'm actually going to put a little bracket here, kind of group those together so I remember those are equal. All right, so when we look at this, we have to identify what's first. And the next person up is Tatiana, I think. Yes, Tatiana.
Is it going to be doing the parentheses, the 10 minus 2?
Yep. So everything we're going to do right now is we're going to do whatever's in the parentheses first. So we're going to focus all of our attention in here. And so that's the operation. Anything in there is what we need to deal with right now. So you're going to do 10 minus 2, right? And that's going to give you 8. So that's what Tatiana is suggesting. That is correct. Now watch what I do here. I'm going to write equals, and I'm going to rewrite the whole thing. 5, take away 3, plus 72. And Tatiana, you said that the 10 minus 2 becomes an 8, right?
Yes.
Okay, so when I put 8 here, what do I need to put between that 72 and that 8?
The parentheses.
Okay, so I could put a parentheses. I could do a parentheses around the 8. That would be fine.
Could you also do multiplication?
Yes. So my question was really, what is the operation that's happening between the 72 and 8? It's not written, right? There's nothing there, but it's understood. So it's what we call an implied multiplication. It's implied, right? It's implied that there is a dot right there, and that means that up here there was a dot. That's implied multiplication. So we got to remember that, because when we're doing order of operations, we would do multiplication before we do addition or subtraction. So we would have to handle that first. Okay, so let's move on. Let's go to our next contestant, Victoria. Victoria, what happens next? There you go.
You would multiply.
Yep. So you're going to do the 72 times the 8. Right.
By 8.
Mm-hmm. Okay, so let's do that. So I'm going to rewrite everything again. I'm going to say equals 5 minus 3 plus. Now you get your calculator out. Do 72 times 8. You get 576. Is that what it is?
Yeah.
576. Okay. You want to keep going?
Sure.
Okay, so what would be the next operation we need to do?
5 minus 3.
5 minus 3. We have to do the subtraction before the addition because we're moving from left to right. The only thing left to do is subtraction and addition, right? So we're going to do the subtraction first. So you go 5, take away 3. That's 2 plus 576. And now you're down to just a final addition. Add those two together. 578. Done. Okay, good. How are we doing on time? Probably have time for just maybe 1 or 2 more. Probably just 1. Let's do number 2. 2 looks fun. 2 plus 2 parenthesis 3 take away 6. Okay, minus parenthesis 1 plus, damn, another parenthesis 1 minus 4 close parenthesis, a squared. And another parenthesis squared. My goodness. All right, so this looks terrible, doesn't it? We've got all these parentheses here. So the way the parentheses work is this. If you have more than one set of parentheses in a problem, like so, say you've got some parentheses over here, and you got some parentheses over here, you can do those separately. Okay, it doesn't matter which one you do first. As long as they're separated by addition or subtraction, you can kind of just like focus on one of them and come back to the other one. Or you could do the other one and come back to the first one. It's really up to you. So for this one, I think what I'd like to do is maybe focus on this first parenthesis here, right? Order of operations, I'm gonna do parentheses first. So let's do that. And I want to try and get through everyone here. We're at Carolyn. Is it Carolyn or Caroline? All I see is Carolyn.
Carolyn.
Okay, Carolyn. All right, Carolyn. So are you okay? We're going to work in that parenthesis. You've got to do that subtraction, and that is what?
Would it be like -3?
-3. Okay, so this is the first time that we've actually had this happen so far, that we had to subtract two numbers where you have this whole issue with like sign numbers. If you have 3 and you take away 6, you're going to have a negative answer. Everybody in this class is at a different place with this. Carolyn appears like she's okay with the idea that 3 take away 6 is -3, but everyone's different. Like, for example, let me just show you right here. If I said, what's -3 plus 6, what's -3 minus 6, what's -3 minus 6, what's 3 take away -6. All of these are just kind of different variations of adding and subtracting sign numbers together. I don't know where everyone is with this, but I'm expecting that you're somewhat comfortable with it. And if you're not, that's something that you're going to need to review, because it's going to come up a lot. Let's just give the answers to these real quick. If you have -3 and you add 6, you should get 3. If you have -6 and you take away 6, you should have -9. If you have -3 and you take away -6, that's the same as -3 plus 6, so that answers 3. And then this last one should be 9. Now, if any of these problems over here caused you trouble, I think we need to do office hours or go to the tutoring. Did y'all get the email I sent the other day? Yesterday, I think I sent an email that takes you directly to our tutoring labs. You can get one-on-one tutoring. This stuff right here is called operations with signed numbers. Signed numbers. So maybe you get some help on that with me or with the tutors, because that is going to play a role here in this section as to whether or not you can do well. All right. Okay, let's continue. We only have 4 minutes left. So Carolyn said that 3 take away 6 is -3. So Carolyn, I'm going to write -3 there. Is that the way you want me to write it? Or should I do something?
I put in parentheses.
I put it in parentheses. In fact, you need to, because if you don't, it's going to look like 2 minus 3, isn't it? But remember, there was a multiplication right there that was implied. So we need to bring that multiplication here. And so we should throw that -3 in parentheses just to make sure we know it's being multiplied. Okay, minus. Now, kind of running out of room there. Grab this, get that out of here, move this over here, okay. All right, so here we've got a set of parentheses, but inside that set of parentheses, I have another set of parentheses. So we've got to do what's in the blue one first, and then we'll work our way out. So did I get through everyone? 20, did not. Alexis? Is Alexis here?
Hello.
Hello. So Alexis, how do you feel about 1 minus 4?
It would be -3.
-3, okay. So when I write that, just to be careful, I'm going to put -3 in parentheses, and then I have this squared here still, and then another parentheses and squared.
Yes.
Okay, good. Let's keep, everyone, let's keep our attention inside this parenthesis. So Alexis, I'll let you keep going. Inside that green parenthesis, what will be the next thing you have to do?
The -3 with the exponent. So you would do -3 times -3.
Yep, because PEMDAS, we are doing what's in the parentheses, exponents comes next. And so, Alexis, we're doing -3, right, squared. I'm gonna do that on the side here. That means -3 times -3, and that should give us 9, right? Positive 9. Because negative times negative is positive.
Yes.
So 2 plus 2 times -3 minus a parenthesis. Then I had 1, and then Alexis just told us that this is going to turn into plus, and all that became a 9, and then all that squared. I'm really running low on time here. Still have to work within the parentheses. Alexis, you're done. You're off the hook. Thank you. Is it Leah? Leah? Is Leah
Yes.
around? Okay. Okay, Leah. What next, Leah?
You do the 1 + 9, which is 10.
Okay, 1 + 9 is 10. So we get 2 + 2 times -3 minus, this all becomes 10, and then squared. Keep going. What do you want me to do next, Leah?
And then you do the exponent, which would be 100.
Yep, so you're going to do this squared here. So 2 + 2 times -3 minus 10 squared is 10 times 10. That's 100. You want to keep going, Leah?
Yeah, sure. And then you're
Okay,
going
what's
to do
next?
the 2 times -3, which would be -6.
Yep, multiplication is the next thing that we see. So we're going to have, I'm running out of room. 2, what does it become?
-6.
-6. So that's going to turn that plus into a -6. And then we still have -100. Okay, so it's real important to understand that this right here, even though there's a plus symbol here, the fact that this turns out to be -6 turns that plus into a minus. Okay, now do the 2 take away 6, right? Move left to right here.
Be -4.
-4, and then take away 100 from that.
It'd be a -104.
Good. Okay. I know I had to go through that a little quick. Here's what I would suggest you do. Over the weekend, get as much of the homework done as you can from the previous section with these word problems and stuff. And then maybe start looking at the homework for the order of operations. Let me scroll down here so we can see what the homework looks like. Maybe you can start looking at this page 13 and just see what you can do. I mean, I'm sure there's gonna be some issues, but it won't hurt to maybe just play around with it a little bit and see what causes you problems. But that's where we'll start on Tuesday. I'll pick up with more examples in order of operations. That's all I've got now. So you're free to go. If you have any questions, I'll hang around here for a few minutes. And then also remember, I do have office hours today on Zoom from 11 to 12:30, I believe. Okay, have a good weekend. Thank you for your participation.
Thank you.
I just had a quick question. The
Yes.
homework is page 11 or is it page 13?
Well, it starts, hold on. Yeah, so I hope our packets are the same. See where it says homework, page 13? So if it doesn't say homework at the top of the page, it's not going to be homework. Like, see how this says linear expressions? These are all the things I'm doing in class.
Okay.
Okay, so see how it says order of operations? The only way it's a homework set is if it says homework at the top, like this one, see? So these are homework problems.
Okay, thank you.
Yep, this one, that's homework problems. Any other questions? Okay. All right, I'm gonna bail out also. Y'all have a good day.